So Ben, shall we get started? I think we're at the hour.
Yeah, we are at the top of the hour, so let's go ahead. This is Saag, the Security Area Advisory Group. I'm Ben Kaduk, and Roman Danilo, you already heard talking some. So we have the ADs, and let's get started. Hopefully everybody has seen the note well already. The standard IETF IPR rules apply. If you have not seen the note well already, please do take a look. Those are the rules that we operate under. So let's keep going. So we've got, go ahead.
Oh, sorry. I was just going to say, I mean, we have this specific agenda, but before we even get into the details of the agenda, I just wanted to provide kind of a top line view of what Ben and I have been thinking about this. I mean, we realize that the virtual format is incredibly difficult for us, and I think we've been doing as good of a job as we can kind of with that work. But one of the things that we're always cognizant of that we may have lost is just that informal discussion that leads to situational awareness about what's happening related to SEC issues across the IETF. So one of the things that we're trying really hard, and you see that reflected perhaps in the agenda, that we're a bit more internally focused than we may have been pre-pandemic. And that's an explicit choice. What we're trying to do is to find topics perhaps across the IETF and just bring them to SAG to provide that visibility. You know, one part of that is, you know, we've been harping, I think, a little harder than usual about getting working group summaries as well. We think this is just really important to, you know, just take the time to summarize what's happening across just SEC and make that a little more easily accessible to everyone else, both in SAG and outside. And the other thing you'll notice is we have OAuth at the end of the agenda. And this is actually going to be the second installment of what we started last time with DOTS, which was finding SEC work that has made a lot of progress on their deliverables, and to just really step back from the individual documents and have the top level kind of introduction to what that work is about and what it's doing, and potentially where it's headed in the marketplace. And so it's OAuth's turn to do this, and we're going to continue choosing working groups in future meetings. And the choice of OAuth is quite kind of deliberate. We had a couple of options. I mean, this is also a response to, you know, we got some questions that we don't understand what OAuth is working on and what OAuth is. And so we hope to address some of that there as well.
Yeah, and of course, if you have a topic that you want to hear about, please feel free to let us know. We're always open to feedback.
Yeah, absolutely. I mean, if the group has feedback on how we can help with that awareness, I mean, we're all ears. Okay, thanks. Let's talk through the agenda.
Yeah, I mean, I guess it's been up on the screen. If anybody has any suggested edits or changes, you can join the queue. But we should probably just keep going because we do not have too much time left in the schedule.
Okay, so I heard no agenda bashes. So, all right. Did you see any? Sorry, I don't have my window up. I'm trying to.
No, I don't see any.
Okay, excellent. Let's move on. So ACE, we have a report. Acme, we had a report. COSI report. Hurdle did not meet but had a report. Did not meet, had a report for DOTS. EMU has a report. GNAP. I2NSF, did we want to say anything here? I didn't see a report unless it just came into the last couple minutes.
Yeah, and you can always join the queue as we keep going, and we can come back if needed.
All right, maybe we'll circle around at the end to see, in the interest of moving forward. IPsec ME has a report. Kitten likewise with a report. Thank you for the report from Lake. Lamps, we'll maybe circle around. We don't have a report there. MLS, we just got one on the list. I just didn't update it in time. OAuth did not meet. We can circle around. Nothing for Privacy Pass. RATS, we have a report. SACM likewise. SEC Dispatch will meet actually after that. This is a scheduling anomaly. This is a little unusual for us. SEC Event did not meet, has a report. Nothing from SUIT. We have something from TEEP. We're waiting for TLS. To point out here, I just wanted to stop. We have a report that did not get included, but there was a call on the mailing list in the last 2 weeks, if the chairs do want to kind of jump in, about what additional work might be, because we're likely to close that working group really soon. Trans has a report. And this is our catch-all if anyone wants to come to the mic to talk about what's happening or to circle around for the places where we haven't had reports.
Right. So I guess my notes say that I2NSF, LAMPS, OAuth, Privacy Pass, Suit, and TLS didn't send one, but the Jabber reminds us that Privacy Pass hasn't met yet. Stephen also notes out that we failed to add OpenPGP to the list. I thought I had synced up with the data tracker, but I guess not. Sean says that TLS should be coming shortly. And I guess we can also note that OAuth, though they're not meeting this week, has been doing a lot of regular interims. And Rowan, you may have a better sense than I, but I think they've been making good progress.
Yeah, indeed they have. I mean, I think we're meeting almost every other week unless something kind of cancels it. And if no one comes up to the mic for I2NSF, I2NSF is kind of at the back end of all their scheduled milestones. So their documents are slowly either responding to the ISG feedback for the ones that have been through a telechat, or they're polishing directorate reviews from a working group last call or from an IETF last call.
Yeah, and I guess Russ is not jumping up to the queue, but Sean is. Go ahead, Sean.
Good morning, everybody. One of the things that came up during the 8446 BIS discussions, which is the revision to the TLS 1.3 spec, was this kind of discussion that we had about adding some more nuance about the meaning of the recommended column. Just kind of a heads up to everybody that we're going to start looking at that. And it actually applies to 8447 BIS, so Ecker is actually technically off the hook. But the idea is to try to add more subtle definition for what that is. So we're going to kind of kick that off. And I just wanted to highlight that because a lot of other working groups are kind of adopting that. And so we're going to try to figure out if there's some better way to do this so that we can reflect the actual meaning of what we wanted it to be. Thanks.
Yeah, that's a really good point. TLS sort of pioneered some ground in making it easy for people to get code points, but still having some indication of what the IETF thinks is a good idea. And we're still evolving what the best way to express that is. So it's great that we have progress there. Joe, go ahead.
Yeah, I can just say a few things about Privacy Pass. We are going to meet tomorrow, session 3. We'll have a discussion of kind of the existing drafts along with some deeper discussion on kind of issuer consolidation. And then there are some new drafts that will be presented in Privacy Pass as well.
Thanks. Hannes, I guess you're already up, so go ahead.
Yeah, I just wanted to mention about OAuth. We are not meeting this week, and but it may be worthwhile to have a look at the upcoming virtual intro meetings that we are planning if someone cares. Obviously, those have been discussed on the list. And once those are done, we can send a meeting report, and we have the presentation later today.
Sure, yeah, well, happy to have the report. Justin.
Yeah, so just two related things. First, in the W3C, the distributed identifiers, or DID spec, is progressing towards community review. And that's going to be of interest to a number of people in the security community. So I would recommend people take a look at that. Also, from the HTTP BIS working group, 2 security-related documents are moving along, making some progress, both HTTP message signatures and message body digest. The second is a BIS. And so, yeah, please, we need to make sure that we have enough, security-focused eyes on those drafts, even though, they are focused on the HTTP semantics more than anything. They are definitely security-related protocols and components.
Well, thanks for the heads up. Taro, go ahead.
this document. I have some comment about IEEE 802.15.4 and 15.9. 15.9 is now going through the sponsor ballot, trying to make a new revision, which actually moves it from recommended practice to standard. And 15.9 provides the key management for 15.4, and it doesn't define its own key management. It reuses existing ones, and it has HIP and IC version 2 and 1X, for example. It doesn't have a TLS because nobody has, volunteered to write that, but it's going to be published quite soon, I guess, in a couple of months or something like that.
Thanks. And I guess the only other thing I wanted to note from the groups that did not already send a report is that LAMPS is working on a new charter. So you'll be seeing that come out for review at some point.
And for those that are still, I would say, also hanging in for the full IETF week, we also have our security-related BOF tomorrow, Danish.
All right.
Okay.
I think the queue is clear, so we should keep moving. So other secondary highlights that the ADs want to call out. There's still 2 AD sponsored drafts, the same 2 as last time. The security TXT had made it through the IETF last call, and I gave some suggestions for how we could resolve the feedback we got there, and then it went to the ISG. The ISG also had quite a bit more feedback for how we could improve that, and so I believe the authors have just this week posted or are going to post an update, and we can get through that. And then the numeric IDs set considerations also went through an IETF last call and got a lot of feedback. I'm still sort of trying to digest all the feedback that we got and try and give some advice to the authors about what the best path is to go forward. I don't have a clear picture for what exactly that's going to look like, but I do think that it's important to get some work done in this space. So we should be seeing something new on that in the next couple weeks. We do have the Danish BOF, as Roman, as you mentioned, coming up later this week. And then the DLT Gateway Protocol was a BOF proposal for this time, but was not quite ready. But I think the proponents are still planning to work on that and try and get some more interest in it. If you want to reach out to them or us, we can get you in contact if that's something you're interested in. So next slide. And we do have a call out for people who might be interested in being a working group chair. There's an immediate need for ACME, and we're just sort of always interested in general, even if you're not specifically interested in ACME, but might be interested in something else, we'd like to know. It's always good to have a sort of broad candidate pool when we do have an opening that needs to be filled, so we can get somebody that's a good fit. And we did have this common SecAD discuss items on the slides last time, but I think it's just worth highlighting. We've tried to make a list of things that show up a lot in our reviews, and we try to get some broader awareness and visibility into that these are common issues, and hopefully we can get them resolved before the documents make it into IETF last call, even to try and improve the quality of the documents earlier on in the process. And let's see, it looks like in the chat, Wes is asking if he should say something about Danish, which I think we
Please,
should.
by all means, Wes.
Okay, I was just typing something up. So I'm one of the chairs of it. I don't know if any of the proponents are here, but the goal of Danish is to be able to get Internet of Things devices being able to cross-communicate a whole lot better. So that includes being able to cross-communicate between themselves in the long run, and it includes being able to talk to other infrastructure besides just the owner of the IoT device in question. And so they want to be able to use Dane to do that, to be able to look up both keys for other devices and things like that, as well as to be able to look up keys for other organizations and things like that, rather than just rely on the PKIX infrastructure for doing that. It's a discovery mechanism too.
Thanks.
Thank you.
Obviously be at the BOF, so look forward to see how it goes. All right, so I think we can go to the next slide. Yes, so we want to put this in. We do have in the data tracker, there's a very handy feature that shows sort of the AD dashboard of where all the documents are that we're responsible for, and it breaks it down by the category of what is in publication requested, where it's on the AD to take the next item versus getting reviewed in various states and whatnot. So you can always go and look at those. It doesn't require authentication and track how we're doing. I think Roman did a good job this time and cleared his publication request queue. I did not do quite so well. I still have a couple documents in the queue, but I'm making progress on them.
Yeah, one of the questions we've gotten is, I've been working on my document, it's in the working group, it's now out of the working group, like what happens next, kind of what else kind of is in the workflow as it relates to SEC. So looking at these dashboards for either kind of Ben or me gives you insight into what happened after it left the working group and what else is on deck, as it progresses through the different phases. So this isn't necessarily new information. You can see that information on particular documents as they're buried in working groups. But if you want to get a sense for what's in the SEC pipeline and how far it is in the progression process once it's outside the working group in a place aggregated, aggregated in two places, because that's how it's kind of split. You can just look at these URLs and kind of self-serve. Okay. So I think the next thing is just kind of moving through slides to keep us moving. We wanted to just put out another big thank you, as we always do, to all the sector reviewers who make all the IETF documents, either in last call or before they're published, so much better because of that review. We, of course, would always want everyone to consider security early, but the sector reviewers primarily make sure that even those that don't take the time to think about it early, we still think about it at some point in the process. And on a personal level, I mean, it's just so helpful to Ben and me to have that as we come into the telechat, and early pokes that this may not be ready really helps reprioritize our time. So to each and every one of you, kind of thank you. And, a special kind of thank you to Tero, who actually manages as our secretary, kind of manages the workflow and kind of the pipeline with all of these reviewers and all the different working groups. I mean, it's really a thankless kind of job to kind of do it week in and week out. So very much appreciated.
Yes, definitely thanks to Tara and to all the reviewers. Going through the list of reviews to make this slide is really sunk in just how much work you've been doing, and it really makes a difference. So thank you.
Okay.
All right, so now we're on to the talks. So Robin, you are up.
Yep.
You want to just kind of shout out to next slide? I'm happy to progress you now.
Oh, that's fine. All right, so thank you all for giving me a little bit of time to talk about this. About QLog. Next slide. So QLog stands for Quick Logging. Its project started a couple of years ago when we noticed that Quick and HTTP3 were becoming quite complex, and we would probably need some additional tooling to help analyze their behaviors. For other protocols, for example, TCP, you would do that, next slide, for example, by taking a packet capture somewhere in the network and then analyzing that using tools like Wireshark. This is still possible for Quick, but it's much more difficult, of course, because next stands to encrypt almost all of its transport level metadata as well. Next slide, please. So for Quick, if you want to do post-hoc analysis, you would have to store the entire packet capture, including the very large payload, while, for example, for TCP, you could get away with only storing up until the TCP headers, for example. So for Quick, you would have to store it in its entirety and also all of the TLS secrets, of course, which is quite terrible for scalability and privacy when you try to do that at scale. There's a secondary aspect there. what I wanted to say is that it's something that we've historically, of course, also seen for encrypted application layer protocols as well. There's a secondary aspect there. Next slide. Which is that not all aspects of the protocol are always reflected on the wire, of course. Especially things like congestion control, which can be complex to debug, aren't always visible. And so for Quick, we decided to take a new approach. Next slide. Which is to log the necessary information at the endpoints directly, exfiltrate them from the implementations instead of from the network. This is interesting because you can log only the things that you need, and you can very easily leave out sensitive information. For example, this is not a radical new idea. I think many implementations have some way of having some kind of a debug log, for example. But the idea with QLog was to have a single schema, a single format that all the different implementations could use. So that makes it easier to build reusable tooling on top of that. So next slide. This means that QLog is far from rocket science. It's really, really simple. Basically, we map. We have a schema of different events that you can have in Quick and HTTP3, and we map that to currently a JSON serialization format, listing how we should, for example, log a received packet, or on the right side, congestion control information. Next slide. Building on top of that format, you can then create tools. We have created a couple of them. There should be a screenshot on this slide, but I'm not seeing it. Yeah. So we have created a list of tools, which is called the QVis tool suite, which, for example, we have a sequence diagram of all the packets going on, and also next slide, things like congestion control debugging mechanisms as well, which has really helped us. For example, the previous tool has helped us to debug Quick's complex encrypted handshake in practice. Next slide. This combination of the common format and the tooling has been relatively successful for us, and this has led to most Quick implementations supporting QLog in one form or the other, with, for example, Facebook using this as their primary way to debug and monitor their Quick deployment at scale as well. Because of this, the fact that it seems to work quite well, next slide, we are now moving for adoption of the QLog format into the Quick working group proper, because until now these has been individual drafts and kind of a non-standard effort. The main goal there is to flesh out these schemas for Quick and HTTP3. One of the main events that is probably interested here is TLS. The TLS related events are really not all that fleshed out yet and could use with a bit of extra work. But there are the secondary goal there is to not just keep this only for Quick and HTTP3, but to expand this to many other protocols as well. Because the general concept of having a endpoint-based structured logging setup can, of course, be useful for much more than just Quick, especially if we continue to move towards more and more encryption at all the different layers that we've been seeing in the IETF, of course. I can especially see this happening for application layer transports, application layer protocols, but also for things like, for example, mask. There's also been talk about doing this for DTLS, for example. Next slide. This goal of having QLog in a more general fashion is also reflected in the current drafts. So we have a separate document for Quick and HTTP3 specific stuff, but then we also have something called the main schema, which kind of has the protocol agnostic stuff. And the goal is there to grow this into a concrete set of best practices and guidelines that other working groups and other efforts can then use to guide their definition of new QLog events for new protocols. Next slide. We foresee quite a few challenges, of course, in doing this, and we also think that this should be like an IETF-wide effort, which is why I've been doing this presentation at several working groups and areas this week. And I just wanted to give you an example of 3 different challenges, so just so you can have an idea of the things we will be discussing. Next slide. So the first aspect there is that the simplest thing to do would be to reflect the raw wire image into the logging format as well, which is what you see here on the left. We have an acknowledgement frame with packet number 16 missing. That's useful, but it doesn't necessarily reflect what the implementation is actually doing with this information. For example, does it immediately mark packet 16 as lost or not? So to know that kind of thing, you need, next slide, a second type of event that explicitly indicates what the implementation was doing. And this is also something that we've seen a lot for TLS, for example. It's not because you get a certain TLS records or TLS extensions in that they're also correctly acted upon, for example. And so one thing to do would be to define the two type of events always, but that makes it a lot more work and a lot more difficult for tool creators to know which data they should act on if there is an overlap tooling across protocols. Next slide. Because of course TCP also has the concept of selective acknowledgements, but there it's not in the frame, it's in the packet header inside of the options. And so you have essentially the same semantic information, but reflected in a different form, making things more difficult. So we hope we can somehow find a way to make this easier, more consistent to work with. The second major challenge, next slide, is to go towards a decent format. We're currently, as I said, using JSON, which is nice and it's flexible, but it's also not the most performant format ever. The secondary aspect there is how we define the event data type definition language, which you can see on the right side. We're hoping to align this a bit more with standard options for that to make it, for example, easy to automatically generate code that serializes and deserializes the events to different formats. Next slide. And then, of course, the main things of why I think it was interesting to bring this here as well is that conceptually it's easy to say that because we're logging at the endpoints, we can be very privacy sensitive. You can leave out the necessary information. However, you can't do that for all use cases because sometimes you really do want the IP addresses or the URLs or other things in order to be able to do effective debugging. And so we're thinking about having a kind of a sanitization level approach where you can say for different levels of privacy sensitivity, this is how you should either hash or anonymize or leave out certain fields and certain events. Something that has also already come up this week is for example, do we want to encrypt the logs themselves? So not just the information contained within, but also the logs that we store, which I think I've seen something here about the core working group for Seaboard that might be interesting for us to take a look at. And there's a separate aspect to that is that we think it might be interesting to have a way of sharing Q logs from between organizations in some way to help make quick manageability better.
Yeah, I mean, I'm just spitballing. Yeah. I mean, I think I guess I shouldn't have said that because I don't. Yeah, and I shouldn't have said that because I think basic. I mean, I don't. It's not bad, but I take it nobody can hear me.
Yeah, we can hear you, but it's not clear what you're what you're referring to me.
Yeah, I guess maybe Ram, you should keep going, and I can come back at the Q&A.
Yeah, it's just one more slide, so we can. I kept this to the last so that it would be fresh in everyone's mind. So I'm not just to immediately come into that. I'm not saying this is a good idea that we want to do this. I'm just saying this is something that we've been talking about.
No.
We can hear you sometimes and sometimes not, Hacker. But so to conclude, we're thinking about these privacy and security issues of this, where we can take this, how we can do this in a secure way, and that's why I wanted to make people in this area aware of this work that's happening. So last slide. Eventually, we hope this work will go to its own working group that will be able to do this in a more generic fashion. But for practical reasons, for now, we're starting this in the Quick working group. So if you're in any way interested in that, please find us there in the coming months, which should be part of the rechart of the working group. And we're also, of course, on GitHub, and we have a separate mailing list as well. And of course, I'm more than happy to answer any questions or listen to feedback you have right now. Thanks.
Yeah. So thank you again, Robin. Roman, just so you know, I did mute you at the start of the talk, so you'll need to restart if you want to comment. And also, I apologize to Robin. I told you I was going to give you a nice intro about what the goal of the talk is, and then I totally forgot to. So I put it in the chat, but
okay.
I think it sort of became clear that this is a thing that people have been using for Quick, and it's quite effective. But there's also still some open questions in terms of how to make it broadly applicable to new and existing encrypted protocols in general, and so to make it broadly useful and sort of improve and deal with some of these open questions that you mentioned. So it would be great if we can get some feedback from the people here, whether now or in the Quick or the future working group where this gets taken up. So the queue is open. It looks like Stephen, you are first, so go ahead.
Yeah, so I think it's a good idea. I just wonder, have you kind of thought about how this relates to PCAP files and Wireshark and the like, which people are also used to using for similar purposes? And the second part of that is the sense that, the privacy sensitive information that is in these files, that problem exists for PCAPs as well. And I don't think it's been solved very well. So again, I think looking at that would be good.
Yeah, we've definitely, of course, looked at PCAPs. The thing that we have is what I was trying to say with the event definition format is that they are necessarily very, very much tied to the wire image of the format, and they have some ways of adding metadata annotations, but it's not as flexible as we'd like it to be. But it's definitely I would say a complementary thing. We currently have tools that transfer from PCAPs to QLog for Quick, for example.
Right, and correct me if I'm wrong, but sort of some of the initial motivation is that the raw packet capture PCAP is not very useful because Quick is so heavily encrypted, and so it's actually more useful to have the abstract state dump than just the wire image.
Yeah, but in theory, you could just log in the PCAP format, right? You could exfiltrate PCAPs from the implementations and store an encrypted Quick wire image. But that's something we intentionally chose not to do early on.
Sure. Taro, you're up.
So I guess you are going to be doing some work for TLS also. I mean, one of the problems I have had lately is to trying to debug things in TLS because it's always happening inside the library, and the upper layer applications don't get any useful information, and the Wireshark doesn't tell you useful information. So is there going to be schema describing TLS events or that kind of things? And of course, I don't want to have, for example, it to storing the TLS keys because that would be very sensitive. I don't want to have those locked out, but I would like to have, for example, what certificates were sent, what the client side out failed or that kind of thing. Information would be very useful to get out from there. And of course, it would be very useful if I could be enabling and disabling, so I could actually not only all the time, but I would want to say that, okay, for next connection coming from this IP address, I want to have logs that send them to me. And don't send me too much stuff, send me only the stuff that
Yeah, I'm very sorry, but there's construction right next to me, so I don't catch everything. But the thing is, yes, we want to have a separate TLS schema. We have parts of TLS that we needed for Quick, but I intentionally put off doing full TLS until we also can do something for TCP as well, which is what we're doing right now. And so TLS is a logical next step. So if there are people interested in defining a first version of the schema for TLS, that would be definitely welcome.
Okay, I think in the interest of time, I will cut the queue here with Robin being last, but Phil, you are up first.
Yeah, I was just going to say that one of the things that kept coming up was, is this something IETF should do because it's not protocol? And it occurred to me that it is protocol, in that if you have Alice and Bob who are trying, if you call up customer service and you're trying to debug some, app or whatever, the customer service person can have one browser, the person who is coming up can have another. And you're going to need to have some common mode of interchange so that that customer service piece can be debugged. So there is actually an interoperability issue here beyond the convenience of everybody being able to use the tools. When you think of customer service, you are going to need a feature like this so that you can say, send me the logs.
Yep, and that's, for example, something that F5 have been saying, and they've added QLog to their products as well, specifically for that.
Right, Robin Wilton, you have a question. Go ahead.
Other one, yeah. Hi, thanks, Ben. This is pretty brief, and it's purely about optics, and it's driven by my current paranoia because I'm trying to defend encryption against policies that are hostile towards it. So, two things. The first one is there anything that we can say explicitly that says that although this is a debugging and analysis method that's intended to be used where the encryption is, where the data is encrypted, there's no sense in which it represents a threat to that encrypted data. So that's the optics bit. And then the second one practically is, does this actually compromise the privacy of the people communicating over that encrypted channel? And I think the answer to that is no, but again, it's an optics thing. If we can say something about that, I think it's helpful for those looking at this from the outside.
Yep, I agree.
Right,
so I wasn't sure, because we were interrupted a couple of times by Ecker, but
someone suggested that he might be in two sessions at once, and he gets unmuted in not the one he wanted to.
Okay, that's great.
So great.
And it's fine.
Thanks everybody for the feedback. Robin, I hope you found it valuable. Of course, people can reach out to you in the ways you indicated with more thoughts and ideas, and we look forward to seeing more of QLog in the future.
Right.
So with that, we are just on time. So I think Robin Lee is also up next with application-aware networking. Jianbin, can you join or start sending your audio? Great.
Hello, Ben. Can you hear me?
Yes, we can hear you. Please go ahead.
Okay. Hello, everyone. This is Jianbin. In fact, this is my first presentation in the security area. Yeah, because I'm always have the IETF work in the routing area. Yeah, but because the application-aware networking has much relation with the security and privacy issue, so we would like to take the chance to have your advice on this work. Okay, and also thanks to the secure area to give me the chance to do the presentation. Okay, next slide. Okay, first I introduce the purpose of presenting the APN work in this working group. So in fact, we proposed the APN work in the IETF 2 years ago. Yeah, but in the process promoting the APN work, that means application-aware networking. There's always the security issue and the privacy issue have been challenged by people. So we would like to take the chance to get the advice in this working group. That's the purpose of the presenting. Okay, next slide. Okay, so first I introduce what's the application-aware networking. So this is the APN is focused on developing a framework and a set of the mechanism to derive, convey, and use the attribute information to allow the implementation of the fine-grained user group, application group, and service level requirement at the network layer. So from this the picture, we can see that's the at the network edge, it can tag the application group information or the user group information, and this information be encapsulated in the network layer. So when the packet is traversed to the network domain, such information will be treated as an object. So according to this object, it can be applied to the different policy to satisfy the different requirement, such as the SLA guarantee. So the APN, from this the introduction, we propose this the idea. That means the APN works within a limited trust domain. So the typically APN domain is defined as a service provider's limited domain, in which MPLS, VXLAN, and SR tunnel technologies adopted to provide service. And the APN attribute is tagged and removed at the edge of the limited trusted domain. It's not the case that the application information is being encapsulated in the host or the application. That's the key message in this picture. Okay, next slide. Okay, so here this is the clarification about what VPN is not. So the first one, APN is not about identify the specific application or within the network. So the first we can say that we just need a generalized classification about the user group or the application group, but the APN does not necessary to know the concrete application which send the traffic to the network. So this is the first clarification. So and this is the second one, that the APN is about telling the network what policy to apply to the traffic. So that means the application can be applied to apply multiple policy to different traffic flow, and also multiple application can ask for the same policies. So that means that the policy is used for the generalized application group or the user group, instead of the policy will be applied to a specific applications or specific users. So this is also the clarification. So the third one, I think the APN in the history there has some work which sound similar, such as the SPAD and the Plus network token. And also there's some work as the PAN-RG. For the PAN-RG, that's the different, because that's the that means the application who can be aware of the network information. But for the APN, that means the network can aware of the application information. That's the different aspects. And for the SPAD and the Plus as the network token, the idea of this work, the similar part is that it always encapsulates the application information in the host and all the applications. So this means the information will be traversed along the whole internet. That's the information to be carried end to end along the internet. So we think this will introduce the more security and privacy issues, because that is always open to the whole internet. But the APN is only to be applied in the service provider's limited trusted domain. That means the application information will be tagged as a network edge. But when the packet leaves the limited domain, the information will be removed. So we think that the information is only be applied in the limited domain. Well, this is a third one. So that's in the past 2 years, we have the 2 APN related side meeting. So that's in the IETF 18. So we asked the brain tremor to also introduce this the SPAD and plus work. And in the side meeting, we clarify that the convey in the information. So that's the PRG and for the SPAD and the plus network token. There's another common thing that is because it encapsulates the application information as a host or by the applications. So this information can be carried by the transport layer or the application layer. But for the APN, because that is always the application group information and the user group information is encapsulated as a network edge, so that the APN the application aware information can be encapsulated in the network layer. So in summary, we try to clarify that the convey the information through the transport layer, application layer, is different from that work that the information be encapsulated in the network layer. So this is the information we would like to clarify in this part. Okay, next one.
So Jim, just in the interest of time, maybe for the next few slides, we can just touch on the very important points and then get to the Q&A topics.
Okay, yeah, thanks. Thanks, Ramendi. Okay, so here this is give a use case about this the SD1 because it's very popular. Yeah, and also the MEF defined some of the standards. So here this is refer to the MEF 70, the standards. So that means in the CPE. So according to that the 5 tubes information can map this the traffic flow into the different one line. But when enter into the one, there's still the multiple paths. So in order for the different network paths, there can be the different SLA guarantee characteristics. So in order to satisfy this requirement, we think that there's a need to carry this the application information when enter into the one. So that in the one, so that according to this information to mapping the different network paths for the specific SLA guarantee requirement. Okay, next one. Okay, so this is why the APN. So now that is the in order to implement the requirement mentioned in the above this the SD1 use cases. So we need to map to the different network paths. So that's we think that's the convenient one. So this we can use this the information of this can convey this application group information or the user group information to the network is an easy way. Or else if we use the 5 tube of this the IP packet, because when enter into the one network, so the tunnel will be encapsulated before this the IP payload. So that this 5 tube information is difficult to be achieved in the network. So that is hard to take use of this the 5 tube information for the specific SLA guaranteed requirement. Okay, next one. Okay, so here I will not repeat this information. So here is just to convey this information as a network edge and to the and is along with this the packet to traverse this network. So this can get some of this the benefit. So this is easy and also only the one fuse instead of the 5 tube It can also improve the forwarding performance. It can also use the other purpose, such as to guarantee this use the information for the security or for the performance measurement or for the SR guarantee. Okay, next slide.
Yeah, I think maybe, can I suggest we skip to the frequently asked questions and then go directly into the specific questions for this group?
Okay, so next one. Okay, so here is just a quick, this is, there are some, this the existing information, but we think that solution is not generalized. So we think that we need a generalized information to carry this the application aware information. Okay, next slide. Okay, so here this is frequently asked information for this one. In fact, this also mentioned in the presentation in the dispatch working group on this Monday. So here this summarize. So this are there any applications that can benefit from the APN? So in fact, we think that is according to the experience of the Meet Echo of the IETF meeting, we can say that the QoE can be improved, and we think that the network can play a role in this one. And the second one is how can APN help us resolve this QoE issue? We think that APN can help resolve this QoE issue through the network, but QoE cover that more aspects, so that is not only to solved by the APN. And the third one, who is to set the APN attribute. So that is mentioned, that's a network edge. And how to set this the APN attribute. So that we think there's the different way according to the existing information of the packet. The basic way is to use this the 5-tube to map to the corresponding the user group or the application group. And this advanced way, maybe we can use some of the AI-based method. There's also some of these papers for this work. And last one, so this is how the APN attribute used in the network. So this is just in the head end to steer to steer this the traffic, and the midpoint. So that's either for the performance measurement or some this the necessary process in the midpoint. And this is the, and also we have some of the SFC the function. So that's for the service function. It can also execute specific this is the policy according to this the application information. Okay, so next slide. Okay, in fact, this is the last slide for the presentation. So we introduce the scope and the possible clarification of the APN work, and also introduce the frequently asked question. So here, that we would like to get more advanced, especially about the security issue and the privacy issue. So here, this is the question. So we want to learn that from the experts in this area. So what are the security issue may be caused by the APN attribute encapsulated in the network layer, and also used in the limited domain. And also regarding to the privacy issue, so we also solve this the possible way to mitigate this issue. So the first we think that is just is the group information instead of the specific application or the specific user can hide the details of this the specific application or the user. And also because this information when conveyed, that use the opaque value. And also that is the information, and also this information and used to apply the different the policy. So that is just the some of this the possible way to mitigate the privacy issue. Okay, that's my introduction about this work. Okay.
Thanks, Jinbin, for setting us up for the important questions that you want feedback on. So the queue is open. I see several people in it already. Okay. So let's start with Watson.
Okay.
Counselor, I have a question about how does the customer premises equipment know the application that's on the end user device?
Here, that's the proposed this way is that we can, according to this the existing information in the packet, the basic information is use that's the 5-tube information in the packet and map this 5-tube information to a specific user group or the application group. So we need not to know this the concrete user and the application information. Yeah.
So you assume that you already know the 5-tuple for the flow of interest?
Yeah. That's the way. Yeah.
Stephen,
okay, so
you're up next.
Yeah. Yeah.
Hi. So earlier you said this is not the same as Spud or Plus, and I didn't understand why that's true. It seems to me that all of the many objections to Spud and Plus also apply here. And I don't see that any of those objections really addressed. So can you say why this is different from Spud and Plus from the point of view of security and privacy objections to doing either?
So this is just my doubt about this security, this the privacy concern. Because for us, that's this information is used in the limited trusted domain. So I think the security and the privacy issue can be under control. And also we know that the 3GPP and the BBF, there's the similar way to because they need to authorize the user information, so that they also have this protocol to do like this way. So I'm a little confused about this one. So that is why I'm here for the clarification.
Yeah, I mean, I think that the clarification for how this is different than Spud and Plus might be something we have to take onto the email list or out of band. I don't have high hopes that we would resolve it today, and we do have a few more people in the queue, so I think we should probably keep going.
Okay.
But, Stephen and Jimbin, I hope you can continue to explore this topic. David, please go ahead.
Okay.
Hi, David Skenazy, Internet Architecture Enthusiast. I glanced over the main document and also the security and privacy considerations document, and I've been listening to your slides, and I feel like there's a contradiction. So maybe you can help me clear this up because I'm probably misunderstanding. So is the idea that the end device, so let's say my phone, for example, is going to add some information so you can tell that I'm running Meet Echo as opposed to, downloading a large file? Or is this going to be added by another device like the CPU? Can you clarify this, please?
Okay, David, thanks for your question. So this is just the clarification. This is just as to your use case. This information is not encapsulated by your mobile phone or by the applications on your mobile phone. So we think that information can be encapsulated by the base station or the eNode B, and that means this is the wireless network product. So because this is the network device as a network edge, so it can encapsulate this information. So that's this the case. Yeah, because for this one, we need not to understand this the concrete this application or this the user information. Either just is the course application group or the user group. They may have the different SLA requirement or some this the security requirement. Yeah, that's the case.
So thank you. In that case, if it's not being added by my phone, if it's added by, let's call it the network device, how does the network device know to add information from my Meet Echo flow as opposed to my file download flow? How does it know that?
So this is the first one. I think that's the, for me, I think that's the, I think this one. First one, I think because I'm not sure about this, the process of the Meet Echo, but I think, for example, because this is the IP packet, maybe has this the destination address, it has some this is the, this is the server destination according to this server. This destination, maybe we can encapsulate as some this as some this specific application group. So that's is this the case. And the second one, because in the 3GPP, because when especially for the mobile, in fact, when you that's the be access to the wireless network, so need to negotiate with this the cloud core network. So the cloud core network can learn this the user information, and they will set up the GTP tunnel. So that the GTP tunnel, they have some this the queues information and also has the TEID information, which can carry some this the user group this information. So this information can also be reutilized. So that's this case.
So this user group information, is that something that my phone is putting on the packet then?
So I mean that when this the packet will be encapsulated in the GTP tunnel. So that's the GTP tunnel. When the encapsulated GTP tunnel, so that's here this can have some this the application aware information.
So apologies, I am not familiar with this. The TTP tunnel, does that start on my phone or does that start on a network device?
No. GTP tunnel is used between from this the base station to the base station controller. Is just
Okay,
yeah.
No, sorry, I feel like we're going in circles a little bit, and I just really want to understand who makes the, like, because I suspect that the whole point of this is that there is some traffic on my phone that's going to get different treatment from other traffic. And someone has to make the determination between which traffic is which. So then, the tunnels, all that, that's an implementation detail. Someone needs to be able to make this determination. How does that work?
David, I think they simplify this the answer. I think the first one, I think that's according to that's the original this the destination address or the source address, and can map to some this the application group and the user group. So this information when this the packet is tunneled, so this the information will be go along with this the tunnel information. So that's when this processed in the tunnel, so that can be applied to the different SLA process.
I see.
So
Okay,
that's
that helps me a lot. So my understanding then is you're using information that is already in the packets, let's say the IP addresses, the 5-tuple for that matter, to make a determination of what you want to do with the packet, right?
Yeah, I think that's the basic way, and also that I mentioned that the MEF, the SD1, they propose this the standard.
I see. Okay, thank you. No, that really explains things. So then, if you can make all of the choices you want from the 5-tuple, oh, where'd he go? Am I the only one who lost video and audio here?
No, we also lost it.
I'm sure he lost as well.
Maybe let's
I can still
pause
see you.
here for him to come back.
Right.
His browser just dropped and reconnected. You can see it in the Jabber logs if you're looking directly via XMPP. It happened to me earlier. I think he's back.
Yeah, all right, thanks. I'll pause here because and now I'm finally understanding. So I have a question, final comment, I guess.
Hello?
Yes, you're back. Okay.
Okay, sorry, I lost.
Yeah.
Okay.
No worries. So let me back up just a little bit. So I was saying, thank you so much for explaining this. This really, really helped me. So what you're saying is that from the information that is already in packets today, like the 5-tuple, you can make a determination on how to handle these packets. Therefore, why don't you just do that? Why do you need APN at all? It seems like you already have all the information you need. Why do we need this new protocol?
Okay, I have mentioned this one in the slides, but not take much time because this is the IP packet will encapsulate in some of this the tunnel, such as this the MPLS tunnel or some of this the VXLAN tunnel. But when this information is be encapsulated, so that the tunnel, the packet be traversed along this the network node, so the network node cannot learn this the 5-tuple information in the IP payload. So we need some this the application group information and user group information that used along with this tunnel.
Why don't you just copy the 5-tuple into a specific spot in your tunnel and use that then?
Okay, good question. So I also mentioned that one. If we use this 5-tuple information, there's some this the drawback. So the first one, the 5-tuple information, so that's the too much fields. So that's can cause this the forwarding performance issue. So because that's the process. And also that is also the implementation in the network. So that's the scalability will also is a challenge because that's is match the 5-tuple. So that's is need the complex the algorithm process in the forwarding plane. So that's is the entry for the classification and the process is can not be very scalable. So that's this also the challenge.
Okay, if I can just jump in real quick. So I guess the high-level summary here is that because you're already encapsulating in the network, the 5-tuple is an inefficient way to express the information that you need. And I think we're going to have to drop that topic for now because I really want to hear what Ecker has to say, and we're already over time. So
absolutely. Thanks so much for your time.
Okay, thanks, David. Okay. Next one.
Thank you. So yeah, I guess first of all, like I'm finding this pretty hard to follow. Like I've read these documents and I've heard your presentation now, and they seem to say different things. So the documents explicitly talk about injecting the user identity and all this information in the endpoint. I'm referring in this case to draft the APN framework section 4.1. So I guess I'm a little confused. Like, are you expecting the application to the endpoint to inject this information or not?
Eric, I'm not sure. I not catch all your point. Can you briefly repeat your last question?
Sure. So if I refer to draft Lee APN framework, section 4, point number 1, it specifically
section
talks.
4.
Yes, point number 1, where it says service-aware app. The host obtains the application characteristic information of the service-aware app and generates the package that carry the application characteristic information in the encapsulation.
Yeah. Okay. So thanks for your question. So that's in the original draft. So that's we clarify this some of the scenario about this APN work at the beginning. So this scope. So that is I think that's caused confusion because some of these application scenarios mention this is the network side. Some mention that's the application aware. That means application side. So now that's clarified for the current APN work is focus on the network side, so that we will remove that the use case. Yeah. So that's the point.
Okay. So now I guess okay. So now I'm trying to figure out which information is carried. So you referred, and earlier you said you weren't carrying a user and application ID, but then later you did. So I'm trying to figure out which one it is. Again, this is in the description of app info. So does this carry a user identifier or does it not?
Okay, Erica. So maybe this is lack this the background about what you mentioned. Can you forward the question in the mailing list so I can answer directly in the mailing list? Is that okay?
Okay. Seems like a fairly critical point.
Okay.
I think more generally, we've just spent like an enormous amount of time in working groups like Quick trying to remove as many signals from the network about what's happening as possible. And it seems to me like what you're describing at most requires a very, very small number of prioritization bits. Given that you're distilling it down from what you can infer from the 5 tuple. So to sort of have a framework, we're talking about having like an enormous amount of labeling that apparently includes the application and maybe the user ID, and just generally a method of annotating packets in this way does not strike me as like the right direction for us to go. So I don't think we should do this.
Okay, so we tried to solve this issue you mentioned. I think at the beginning, so when proposed this the APN work, that is we talk about this the application side and also the network side. So that's we align this scope. We and try to align this to update this draft to align with this scope.
I understand what you're saying, but I'm not in favor of this. Thank you.
Okay. Yeah. Okay.
Richard, I think we were still intending to have you ask your question. I don't know if you feel it was already answered.
I think Edgar and David largely covered my concerns here. I think the point that David made about kind of mapping to other technologies, to the degree that this is something observed and injected by the network and observable based solely on network observable properties, it seems like this is kind of a standard tunneling problem, and I wonder whether one of the many tunneling technologies that already exists is appropriate. And I think it's more of a design question of saving bits. I think it's really when we cross the boundary into by the same token, if it's based only on network observable properties, it doesn't seem. I wonder what the utility is because you're not really adding anything that can't already be observed by the network. That's, I guess, a benefit in that you're not creating any privacy risk because there's no information there that the network couldn't already observe. But the utility question arises. So on the flip side of that, if there is information here, if there is information here that the network couldn't just observe, then we have a big security and privacy problem because we need to worry about how that information is protected and who it's exposed to. So I guess I don't understand, based on what's been said here, it seems like there's been some things on both sides of that. Kind of whether this is something where we really need to worry about something or whether it's just something that is like yet another tunneling protocol. So I think it would be really good to be crisp on that point. So let me highlight that as one point, and no need to respond here. We can follow up on the mailing list afterward. The second point I'll raise is that it would be really helpful here to understand, security is all about cost-benefit analyses, take risks to get benefits. So it'd be really good to be really crisp here on what the benefit is to applications of a technology like this, given the A in the name. Like you mentioned Meet Echo as an example, but if you could dive in, if you could have some like worked examples of applications that specifically applications that do benefit from this, and then specifically how they benefit from this, that would help motivate motivate the utility of this mechanism and highlight what are the risks, what did the application have to give up in order to get that benefit, so it would facilitate the security analysis.
Okay, Richard, thanks very much for the information. Okay.
Yeah, so Jianbin, I hope you got some of the feedback you were looking for. I think there was also some discussion in the Jabber room, so hopefully you can look through that as well after the session to get some more feedback. Okay. We are, of course, over time, so unless there's something you really wanted to respond to, I think we should move forward with the agenda.
Okay. Thank you very much for this so rich information. Okay, thanks.
Okay. So we are moving on to John Messon with the AAD limits. It's a topic that has come up in a few working groups, and it seemed worth presenting this in front of the broader audience. So I think we may have enough time to do the full 20 minutes, but John, if you can do it in 15, that would be good to leave some more time for open mic at the end. So take it away.
Thanks. So this is a presentation of, this was shortly presented in core earlier this week, but it needs to be presented also in the security area. Core is not a security working group. There's also, I think there's interest for the findings here for outside of core, for example, for use of CCM 8 with DTLS for IoT or for any other IETF security protocol that would do this work. So this is analysis of the work that has been done in DTLS working group, quick working group, and ongoing in CFRG. Next slide. There's just a list of where this work has been done, and recently core has been starting to looking at doing AAD limits for OSCORE, which I think is great, driven by Richard Höglund. Just short summary of the notation. So this is taken from the CFRG document. So Q is the number of protected messages. V is the number of forgery attempt, and L is the length of messages in number of blocks. And V and Q is per key, unless I state anything else. And there's other reasons to rekey, to limit the effect of key leakage that will not be discussed here. And also this presentation has only analyzed single key limits, not multi-key. And the suggestions here are not intended to be general recommendations. They're mostly at this point input to the discussion. Next slide. So summary of the AAD limit work that has been done in TLS Quick. So you start with some mathematical limits. Then you apply a process. You end up in some explicit limits for V and Q, and then you add these counters and the rekeying mechanism to your security protocol. I think in general this is great. And in general, I think the limits that has been come up in the DTLS and TLS and Quick are great and practically useful, except when you start to apply this process to CCM 8. Then I think you start to see the flaws. So I think this will try to analyze these parts and summarize the recommendations that I have currently given to core. Good to remember that the starting point here is inequalities. They are not maybe tight or tighter, but they're inequalities. And then the process and the CA and IA limits are subject to issues, and there's no mathematical truths behind these. So this could be different. Next slide. First observation is that the CA inequality for CHA 20 seems way too strict, and my feeling is that CHA is treated very differently than AS. In the papers, AS is treated as a random permutation. Also, the paper by Gordon assumes that CHA is a random function. That would mean CA equals 0 for CHA 20. In the work, as I understand in TLS and the CFRG paper, then the Gordon ends up in an AAD limit for CHA, and the CFRG and TLS work has taken that and split it up back in CA and IA. So this limit is, of course, true, but I think the limit here doesn't really say anything useful. I think it gives the wrong impression of CHA. I think it should be changed. Then just the observation that CA and IA is quite different. One is used for online attacks, the other for offline. Can take next slide. How many minutes have I used, by the way?
Used 5 minutes.
Good. Should hurry up. So then analysis of the calculating limits step. This mostly lead to practically usable limits, except for CCM8. I think one strange thing that you get from the process used in TLS and DTLS is that if you apply it to the ideal MAC, you get the result that the ideal MAC needs to be rekeyed. And this, of course, makes little sense and does not increase the security. And our finding is that CCM8 for low Q and V actually behaves extremely similar to the ideal MAC, a 64-bit ideal MAC, and also does not need rekeying. Then, yeah, I think we can move on. Short of time. I think here is a summary of the different inequalities. And it's, of course, very easy to see that rekeying lowers CA and IA per key. But my thinking is that that's probably not the right thing to do for a security protocol where you can have a large number of keys, and you can also have a large number of connections between the nodes. So rekeying lowers IA and CA for a specific key, but might not do the same for the whole connection. If you look at the IA and CA advantage for the connection, you don't need to rekey the linear equations, like the integrity advantage for ChaCha and GCM. The forgery probabilities stays the same. Next slide. See, yeah. Summary. I think that might not be a perfect solution either. It seems like a simpler solution seems to be to calculate security levels based on the inequalities. That would then be calculated as the minimum of attacker cost divided by advantage in the traditional way, and then minimized over all attackers. This removes the conclusion that you need to rekey the ideal MAC, and it also, looking at security levels, have the benefit that if key number 1 has security level N and key 2 has security level N, then the connection also has security level N. Can go to next. So here are some slides, graphs over the inequalities, and we can see that lowering Q and V and L limits, or Q and L limits, raise the security level in the beginning. And here's and that's in the top. My recommendation to core will be to probably lower Q and V L a little bit, which constrained IoT can do. And then the lower are integrity advantages. And as you can see, if you calculate security level, they are straight lines. Next slide. Here is CCM with a 16-bit MAC that behaves a bit strangely. So the reason why they go up is that in the beginning, all the numbers are dominated by Q. And I think if you look at advantage for the whole connection and use attacker cost forgery attempt, then actually rekeying can increase the integrity advantage for the whole connection, not per key and not security level. But we can move on to next. First, maybe the most interesting finding, this is CCM8. On the left is a graph of CCM8 with Q and L chosen as in TLS, DTLS. And you can see that except for in the beginning for low values of V and high values of V, it behaves extremely similar to an ideal 64-bit MAC. If you lower Q and V slightly, which is in the right graph, for example, L 2 to the power of 8 and Q 2 to the power of 20, then it starts behaving like an ideal MAC already for V equals 0. There's a slight deviation that is almost hard to see, but it behaves like an ideal MAC until V equals 2 to the power of 35 or something like that. And this is my current recommendation to Core, that they can perfectly fine with keep using CCM8. Next slide. And here are some general recommendations. I definitely think the limit work done by a lot of people is great. OSCORE should do the same. I think you can use CCM8, behaves like a perfect ideal MAC. So as long as you're fine with 64-bit forgery probability, CCM8 is close to a perfect algorithm for that, at least the integrity part. And I think 64-bit forgery probability is very acceptable for constrained RT. Basically, you need to get a single forgery, you need to send 4.3 billion messages for 68 years, which is extremely infeasible in some constrained IoT radio. Then I think if you heavily use of CCM8, you should probably, for constrained RT, you should probably choose a little bit lower value for L and Q, so you get a per ideal MAC also for low V. And then some further consideration for Core. There has been some discussion in Core to not calculate very hard bounds for different algorithms, but rather to choose a low value and apply that for all algorithms, and maybe to try to make Q and V similar. There was some implementation advantage of that. I think that's it. Comments? Questions?
So I think that one of the questions that came up in the chat, which I don't know if someone was planning to say, but it seems important, relates to like the document in the CFRG. Do you think that document is clear about what it does and does not say, or should there be changes made to it?
I think the TLS and DTLS does not need to change, except if DTLS want to use CCM8, but that could also be done in, for example, the IoT profile. I think the CFRG document should probably change the CA limit for CHA-20, or at least explain it better that this is not likely to be close to the exact limit for CHA-20. And then I think the process should change, it does not give the strange results, so that's ideal MAC should be rekeyed. I think the currently specified process is not ready for a general IETF, IRTF recommendation.
Martin, go ahead.
Really enthusiastic about seeing this going on. Part of the problem I think we're having in this space is that we don't really understand the way to think about these things from the perspective of long-term security and rekeying and multi-user security and the various aspects of this. The discussions that we had when we were putting the draft together essentially concluded that the larger block size and particularly the larger tag sizes were such that you had to have extremely large resources in order to attack, even in the multi-user context. But the smaller tag sizes don't have those same advantages. And my personal conclusion was that CCM8 was really not very good for those sort of settings under those I also think that the assumptions are probably a little bit weak as well. So it leaves us in this awkward position where I really don't know how to think about CCM 8 in this context. It would have been better if we had a larger block size and a larger tag size all around, but I understand the constraints exist. So I think as far as you've gone, the recommendations that you have for CCM are reasonable. But I really don't know if it's going to be the model that applies everywhere.
No, I don't know that either. I see this more as an input to further discussion in CFRD for what to standardize.
Phil, go ahead.
Hi. Yeah. Just a couple of points. Have you been considering OCB? The patents are about to expire, and Rugways just put his patent in the public domain, so it's probably worth considering it. Because what I've never liked about GCM is basically turning a block cipher into a screen cipher. And so OCB keeps it as a block cipher, which is nice. The other thing, kind of like meta, is we really, AES 16-bit block. Maybe we should think about a block size competition for 32-bit, 32-byte blocks at some point, because a lot of these problems would go away if you have a big block.
I have not looked at OCB. I don't know if anybody else have done that. I don't know if there's any advantages published for OCB. It would be very interesting to see. I think for the constrained IoT world, they are currently depending on CCM 8. And I think if there's no major problem with CCM 8, I think the IoT world would like to continue to use CCM 8. Otherwise, they would need to change. Then I don't know if OCB would be a good answer for that. OCB definitely have its advantages in general.
Okay, thanks again for putting this together, and thanks to Martin and everyone else that have actually been working on looking at the limits. It's obviously a topic we want to keep looking at, and hopefully we can make some more progress. So thanks, John, for the talk, and we should move on to intro to OAuth. Aaron, take it away. Let's see, do you need to request the share? Okay.
While Aaron is bringing up kind of the slides, again, it's kind of a reminder after you hear OAuth, if you want to give Ben and me a suggestion on what working group you want to hear about next time, we're kind of happy to slot it into the agenda for 111.
Great, thanks. So yeah, hi, I'm Aaron Parecki, coming to you from the OAuth group. The goal of this presentation today is really to sort of give you a sense of what OAuth is, what problems we think about, sort of the way we're approaching the world. And this is going to be a mostly high-level session, so mostly not a lot of on-the-wire protocol stuff, more about the high-level concepts and architectures of the different parties involved. And towards the end, I will catch you up on some of the new work being done in the group as well. So I want to start off by saying that specs, it turns out, are actually not a great way to learn about this stuff, as I'm sure you're all aware. Specs are, the legal contract that we are all writing, and in the OAuth group, yeah, it turns out that the OAuth core spec written now almost 10 years ago, there's been a lot of progress made since then, and it is a bit of a mess. It is definitely a bit of a mess. There's a lot of different extensions. There's a lot of work being done in other groups as well, outside of the IETF as well, building on this work. But I want to take a step back from all that and rewind back in time to talk about how we actually got here, which is this what used to be a very common pattern on the internet, which is when an app like Yelp, not to pick on Yelp, but when an app like Yelp would launch, they would want to see if your friends were already using Yelp. They offered you to, bootstrap your social network within this new application. And to do that, it would ask you for access to your contact list. And where is your contact list? In your email. So to ask you to enter the email address and the password to your email. And this was a very common thing, like even Facebook was doing this. We understand that this is a terrible idea now. It is generally understood that we should not be giving our email credentials to random applications, right? A couple of very concrete problems with this. How do you decide that if you no longer want this application to have access, that you can revoke that access? How do you actually know that that app is not going to store your password, for example? How do you actually know that it's going to only do what it's saying it's going to do, which is reading your contacts and not actually reading your email? And you actually trust that app not to do things like changing your password or deleting your account. So the fact is that people were happily putting in their email passwords into these apps because they wanted what the app was promising, which is to find their friends. So we need to find a solution to this. Otherwise, people will just keep doing this, putting their passwords into random apps. We would like to find a solution that lets Yelp access some part of a person's account while not having to be able to access other parts of the account. That's sort of delegated access. And this is really the problem that OAuth set out to solve a long time ago, which is how do we let apps access data without sharing passwords with the apps? So what used to be the sort of, you give your password to the application, it then sends that password to the API. That's the pattern we're trying to avoid, especially because of the third-party app scenario. What we would like to find is a solution that lets us avoid sharing passwords. So we're going to need to exchange the password for some other thing, and then use that thing with the app to go and make requests to data. So this is the sort of high-level concept of what we're trying to do. And to bring this into the real world, I actually like to use this analogy of checking into a hotel, which is when you go to a hotel and check in at the front desk, the person at the front desk will hand you a key card. That key card is what you take to the door, and you can go and access the room on your door with that key card. This is exactly analogous to OAuth, where the person at the front desk is the authorization server handing out these key cards. The key card is like the OAuth access token, and then that door would be the resource or the API. So that key card may give you access to your room, it may give you access to other resources in the hotel. And the important thing here is when you are using that key card, you don't need to know how it works. You just need to know the thing that you're sending it to knows how it works. And it doesn't even need to represent a user. It doesn't need to have your ID written on it. It doesn't need to have anything about you as a person. It represents access to data. And what that means is that because OAuth was created to solve this sort of delegated access problem, there's actually nothing in the spec that talks about users. There is no user identity built into the OAuth spec. It's always about accessing data. So OAuth started with that problem, and then because it is actually very common that applications do care about who the user is, then the OpenID Connect group built on top of the OAuth spec to add back in that user identity information. So I want to start with a bit on how OAuth works, and then we will touch on some of the user identity aspects that are built in later as well. So in the OAuth terminology, we say that the goal of the client application is to get an access token. That's sort of the end goal of the client. Get the access token to be able to make API requests. And then how that client is going to get the access token will depend on a whole bunch of different things. It depends on what kind of app it is, where it's running, the different security properties of that client. In the OAuth terminology, we say that the client will use an OAuth flow to get an access token. And then there's several different flows defined in the spec, as well as some extensions. And there's a couple that are defined in the spec that are being undefined by some new extensions. And regardless of which flow was used, the end result is going to be the same. The end result is the access token. The app has the access token. It's going to then put that into an HTTP header, make a request to an API. So, okay, let's get into some terminology here. In the spec, there's a bunch of terminology defined. Those are the terms you'll find in the bottom. The in parentheses, resource owner, user agent. Those are the technically more correct terms for the more conversational terms you'll find in bold. We talk about applications, OAuth servers, APIs, but in the spec they're more precisely defined for good reason, but that's why this stuff is confusing to people usually. The point with these is these are roles that the spec defines. These are not necessarily always discrete physical components. So we might see this expressed differently in a particular deployment. For example, GitHub has a piece of software that is both an API and an OAuth server, or a resource server and authorization server. And then the client application might be a third-party application accessing data in that API. That is going to look very different from a situation like this, where you might be writing an iPhone app, you might be also creating an API that backs that iPhone app, and in the middle is some sort of third-party service as your OAuth server that you are purchasing, or it's a thing you spun up open source in a different physical deployment. It doesn't matter that this actually looks different in terms of the way that this is architected. We always map it back to the roles in OAuth when we talk about how the flows work and how the different security properties work. So to get into the how the authorization code flow and how the sort of OAuth flow actually works, the first thing I want to do is talk about a concept that we spend a lot of time talking about in the OAuth group, which is front channel and back channel. This is essentially, the back channel is the sort of like normal way of passing data around. It's an HTTP request from a client to a server. And there's a lot of security properties of that we often take for granted because they're just sort of baseline HTTPS. It's encrypted, the request can't be tampered with, the response that comes back can be trusted because it's part of the same connection. And that's kind of stuff we take for granted about the back channel. The idea with the front channel is that instead of a client talking directly from itself to the server, we actually are sending data through a browser, through a redirect-based flow. And it's actually using the browser's address bar to move data around. So I like to think of the back channel as you are walking up to somebody delivering a message. You can see who they are. You can see that the transaction was successful. You can see that nobody came in and stole the data in transit. Whereas passing data to the front channel is more like putting it in an envelope and shipping it in the mail, where you kind of hope that it's going to get there, but you don't actually know for sure if it made it. And there's a problem on both sides of the picture of sending data in the front channel, which is that the sender doesn't know if the message was received, and the receiver doesn't know actually who sent the message, because it's always sent through the browser redirect where you're kind of handing off that message and crossing your fingers that it's delivered. So when we use the front channel, we have to account for the fact that, one, the message may not get there, it may be intercepted or copied, we wouldn't know, and the receiver can't actually trust anything about that message when it receives it. So let's talk about the flow now, the authorization code flow, and I'm going to also include Pixie, which is an extension that sort of solves a lot of these sort of front channel problems in this, because this is the sort of new baseline. The way that the high level of this flow is, the user starts off by saying, hey, I'm trying to use this application, and that's them clicking the button login. The application says, great, don't give me your password, I don't want your password. Instead, I'm going to generate a temporary secret right now and calculate a hash of that secret. We use SHA-256 right now because it only needs to be safe for a couple of seconds. The app then says, great, go over to the OAuth server and take this hashed value with you. Now, this request is actually from the app to the OAuth server, but it's going through the user's browser. So this is the first front channel request. The app is actually trying to send something to the OAuth server, but it does not send it directly, it sends it through the browser. Then that means the user's browser lands at the OAuth server, which is where they log in. That's where they type in their password, or they might be delegated to some other third-party SSO thing at this point. Doesn't really matter, that's out of scope of the spec. That's the business between the user and the OAuth server. they may also then have to approve this request. The OAuth server might say, do you actually want this application to be able to access this data? And if the user says yes, the OAuth server is ready to create the access token. Now, instead of creating the access token and sending it back right now, we're still in the front channel. So we're going to actually send back just a temporary code. A temporary authorization code is what it's called. And this is essentially one-time use and short-lived. So this is the second front channel message. This is the message that the OAuth server is sending back to the app through the user's browser. So this is a temporary authorization code. Now the app can go and exchange that authorization code for an access token. This is a back channel request. And this is where Pixie comes in. This is where Pixie solves this problem. The problem being that when the OAuth server gets this first message, this is the first time it sees anything about this application that the application made, right? And it's not getting this message from the app, it's getting it from the user. The second time the OAuth server sees the application in this flow is the back channel request, which it can actually trust that it is that application. Pixie is the thing that links up those two parts of the request. So in order for the app to make that request, it has to also include the secret to generate at the beginning of the flow, which the OAuth server can then calculate the hash of itself and compare the two hashes, linking up the front channel and the back channel. Now it can reply back with the access token in the back channel. And at this point, the flow is done, and the app can go and use that access token to make requests. So this is the high level of the authorization code flow, including the Pixie bits, which are the bits highlighted in bold. Pixie being the way that the OAuth server can link up the front channel and back channel so that the OAuth server knows that the same thing it's delivering the access token is the same thing that started the exchange. So that's the flow. I want to talk about a few more OAuth concepts as well, starting with refresh tokens. So an access token is the thing the API is going to use, or the application is going to use to make API requests. That's great. That access token might expire at some point for many, many reasons that are basically out of control of the application and entirely up to the OAuth server. Refresh tokens are a way to have the user stay logged in or have the application work offline, however you want to phrase it. Essentially, those are the business between the application and the authorization server to go and just get new access tokens without involving the user again. So that is just a post request, but the important thing here is that it is something that the application can do in the back channel without the user's involvement. So the very common use of this is to streamline the flow in a mobile app, because the mobile apps, the user experience cost of doing an OAuth flow is higher because it involves opening up a browser within the application. And because of that, it's useful to use refresh tokens to smooth that over. So you'll see that the application will start the OAuth request. The user will see a browser prompt, log in there, delivering the access token and refresh token to the app. It can then store that refresh token itself so that the next time the app launches, it says, oh, I've got a refresh token. Let me go and unlock it with biometrics, go and use that without the user's involvement, and it'll get back a new access token. So that's a way to sort of streamline the user experience on devices that where the cost of doing that flow, that redirect flow, is higher. Another really important concept in OAuth is the idea of scope. This is a way to have an application request limited access to data. So without scope, the access token would be able to access any API endpoint within that API. The idea with scope is that we want to say, actually, this application is only going to get access to this particular data. And you might see that in these consent screens like this one, or with Fitbit, where you can see, like, great, we can access, your sleep data, food data, whatever, or the user might uncheck certain scopes. The important thing here is that this is a request by the application. The application saying, I'm trying to get this data, and that request may or may not be granted. It may be confirmed by the user, and it may also have, the authorization server might have its own policies about which applications are allowed to request certain scopes, things like that. It's all sort of the business of the authorization server. Okay, the I want to talk briefly about access tokens, since this is a pretty big aspect of OAuth as well. Access tokens are, of course, what the application uses to get data from the API. They are mostly considered an implementation detail within a particular deployment of OAuth. There's actually not a lot of hard-coded rules about what access tokens should be or how they should work. It's a lot of decisions that the resource server as well as the authorization server can make. So generally, we consider access tokens fall into two families: reference tokens or self-encoded tokens. In both cases, these are considered bearer tokens, which means if you have the string, you can use it. That's all it takes to use it. These are not key-bound tokens, even if there's a key that was used to sign the JSON Web Token. Once it's handed off to the client can use it by just presenting the string. The idea with a reference token is that the token string does not mean anything. It is a random string of letters and numbers, and it is a pointer to a record in some other database. Data about that token would live somewhere else. So the expiration permissions, whatever it is, that would live in some other database. Whereas a self-encoded token actually takes the data that is trying to be stored about the token, packed in some sort of serialized format, signed or encrypted, or both, all the same. That's all a self-encoded token. There's many different ways to implement both of these families of tokens. The advantage that that self-encoded tokens give you is that you then have two different ways to validate them at the API, at the resource server. What we call local validation, or the fast way, is because it's a signed token, you can look at the token itself without going externally over the network, and you can decide whether it's valid. You can also use what's called strong, remote introspection, or the strong way, which is you do go back and call the OAuth server and say, hey, is this token really still valid? And that lets you do things like check whether a token has been revoked for some reason before it has expired. And these are the different trade-offs that you have to make in the different token validation methods based on whether you care about things like early revocation of tokens, based on the timelines of the timeline of the token lifetimes and things like that. So the classic example here is, let's say your tokens last for 8 hours. The two different ways you validate tokens will agree at first until something about it changes. Once the token's been issued, that a self-encoded token has been issued, there's no way to change the token itself, so you can't revoke it. So if the user goes and revokes the application, or the application is deleted, or something about that changes, like the policies of the user change, that isn't reflected in the token, which means the two different validation methods disagree until the token expires. And then you have to decide what is your threshold for being okay with the fact that these two different validation methods disagree. And this is something that you can't really avoid. This is not even a unique problem to OAuth. It's essentially a caching problem. Self-encoded tokens are basically a cache of the data at the point it was created. So, okay, that's what I want to talk about how things work. I want to wrap up with just a brief overview of some of the current work being done in the group and sort of future directions that things are heading. You may have heard some mentions of OAuth 2.1, which is essentially an effort to consolidate the best parts of OAuth 2, the things that generally the industry has agreed are the best practices of how this stuff should work. So if you actually look at in the field, there is a generally accepted best practice, and a lot of the optional bits of OAuth 2 aren't being used, things like that. So OAuth 2 has grown into a kind of mess of a bunch of different specs and extensions. The idea is to roll those all up into something that actually represents what is being done, but in a document that is a lot smaller and easier to get started with. So that effort is happening ongoing right now. There's also a profile for access tokens, because a lot of people do implement access tokens as specifically JSON Web Tokens. So that work is also being worked on right now, where it is a standardized way to use JSON Web Tokens as access tokens. There's a couple of new features being added in extensions as well. Rich authorization requests is a way to it's an extension of the idea of scope, where scope allows you to access sort of high level buckets of types of data. This would let you authorize specific transactions for specific dollar amounts or between specific accounts, things like that. Push authorization requests is the idea of reducing reliance on the front channel, move more of the flow into the back channel. That way we again can kind of smooth out some of the security properties of the flow as well. There is a lot of use, so OAuth is being used by a lot of other groups as well, being built on and extended in a lot of different ways, sometimes in, again, different organizations. So I just threw a few of them up on the screen here, and that is where I want to end. Thank you all very much. This was a whirlwind. I hope this was helpful. Hope this gives you an idea of how we are thinking about things.
Yeah, thanks a lot, Aaron. That was a really enlightening talk. I think it's real helpful to present it in that way for this audience. Do we have any Q&A or comments? People feel free to join the queue. Do have a few minutes left. Seeing some comments in the Jabber of thanks. That was a good talk. DKG, go ahead.
Aaron, thank you, Aaron, for the presentation. That's one of the clearest presentations of OAuth I've ever seen. So appreciated. I didn't actually understand in the first flow that you showed, the first front door flow where the app is asking the user to get the token, how the user could confirm that the identity of the app that they were actually granting access to once they're interacting with their OAuth server. That seems like, I mean, there's a whole separate set of questions about how does the user understand the scope of data that they are granting access to, which are maybe maybe we can't discuss here. But certainly with the parties that are involved, it seems critical that you understand who you're granting access to. And if the data pass is merely a blob provided by the person who's requesting the data, it's hard to see how that ties to their identity.
Yeah, I kind of glossed over that in the flow, but it is that consent screen of the OAuth server prompting the user to log in, and then that is where they will sometimes see the request described on screen. Like, this application is trying to access these parts of your account. That's entirely encapsulated at that point in the flow.
Right, but where does the information about the thing that is requesting come from? Because given that it's a front door flow, it's like it's all being passed through the user's browser or the user agent, which doesn't necessarily know how to translate that bit.
Two parts to that. So the flow is started with, so every application has to be registered at the OAuth server. That's generally how it works. There's a registration step establishing an identifier for the application at the very least, and in some cases a password or a client secret.
So that's a back channel discussion that happens earlier.
It's usually actually out of band. It's like the developer goes to the website and registers an application. There is a way to do it with an API as well, dynamic client registration, but that's much less common. More often it's literally the developer goes to the website, signs up as a developer, goes and creates an application, uploads an icon, and things like that. That gives it an identifier, which it can use in the flow. And then that identifier is passed in the first request from the application, which now, to get to your second point, how do you know it's really that application? If the app has a client secret, a password, that's used before that's required in order to actually get the access token in the back channel. And that's sort of the how we can make sure that it really is that application doing it. Not all apps can use client secrets. Some apps can't, like mobile apps and single page apps, in which case that is kind of a big, gaping hole in this, and there isn't really a way around it. Of you can't actually tell if somebody is impersonating a mobile app or not, and that isn't something that can really be fixed on the wire without cooperation of, for example, the app stores. But the best we can do there is rely on the redirect URL of, like, where is the user going to be sent back to in their browser after the flow is complete, and the redirect URL acts as a form of confirming that application's identity.
But if the client is malicious, they might be happy, as long as they get the access, they might be happy to redirect back to the other one, right? Or no, because they can't, because the redirection is what closes the loop, right?
Yeah, the redirection closes the loop, but there is also ways for a malicious client to cooperate with a user to get an access token that both people think, or the authorization server thought, was issued to somebody else. And there's a lot of edge cases here, as you can imagine, of different aspects of this. And a lot of this is documented in the security best current practice spec as well, of here are the things that you can prevent, here are the things you can't prevent. Here's ways that we're addressing, trying to solve this, or ways that we know that this is a limit.
Okay, thanks.
Thanks again, Aaron. That was a great talk. We are formally at time. Roman, I guess you could bring up the open mic slide just in case there is something that someone wants to say, but I think we should thank all the speakers for their talks, and I'm just about ready to close the session.
I'm not going to bring up the slides. If folks want to open mic, it's easier than trying to kind of flip.
Yeah, it's all good. But if nobody shows up to the open mic, yeah,
I was going to say,
see you in GatherTown.
Yeah, see you in GatherTown. And if folks want to see something different at SAG to help make sure we have the essay across the IETF for SEC issues, please do let us know. And please do let us know if you're interested in being a working group chair. Thanks much.
Thanks.
Bye, everyone.